Why, hello, friends! Jen Foxbot here for another edition of Math Mondays. Da 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 da, yeah! All right, thanks for tuning in to this very special episode where I tackle a question brought to me by a lovely young lady who asked me to talk about how to find area of different types of quadrilateral shapes. Such a good word, quadrilateral. Oh, so good. So I'll be focusing on parallelograms and trapezoids, but I'm going to break this particular topic into 3 sections, and since I always have a lot to share on these topics, I'm going to divide the video into 3 chunks as well. Hopefully that way all 3 topics are a little bit more digestible. So the first topic in this first part, we are going to talk about what is area. What does it mean and where does it come from? We will use that foundation in the second part to derive the equations, or basically come up with from scratch the equations for area of a parallelogram and a trapezoid. That's part 2. And in part 3, we get to talk about how calculus is actually used to find areas of different shapes, and we will use calculus to find the area of a triangle. Yeah, so cool. All right, so let's get started. Part 1, what is area and where does it come from? So let's look at a simple shape. A rectangle. Huzzah! Okay, so rectangles are nice because the sides, we'll call this A, and we'll call that B, because I want to have a generic formula that works for all rectangles. So rectangles are nice because as we're finding the area, A and B stay the same. That basically means that these are constants. So what I do, I say, okay, well, I'm going to break this into smaller chunks. And so I'm going to add up a bunch of smaller rectangles that have a height of A and a width of 1. Pretty straightforward, right? And so now that allows me to count how many of these rectangles with a height of A and a length of 1 add up to make this rectangle. And so in this case, now I have, this is number 2, and then I do another one, and I get 3, and I keep going. I'm going to be lazy for now because you get the picture. And I get to the last one. How many rectangles can fit in this bigger rectangle? I'll give you a second to think about that. What do you think? We have counted B number of rectangles. What? That's pretty wild. Okay, so let's put actual numbers on this. So if I have a height of 2 and a width of 5, and I have a rectangle, I'm going to try and draw this to scale. Okay, so now each of these has a width of 1. And we can say how many of these rectangles add up to create this bigger shape. Well, we've counted 5. 1, 2, 3, 4, 5. That's it. Area is really just counting. Pretty cool, huh? And so now once we have figured this out, we can say, aha, the area of a rectangle, well, that looks like a square, but a square is just a special rectangle. So the area of a rectangle equals the height, in this case it's A, times the width, in this case it's B. And that works for any type of rectangle, including squares. So squares, you would just have A equals B, so you would have A squared. No problem. Pretty rad, right? Okay, so now let's apply this technique to a triangle. Ah! That one's a little trickier because check this out. Okay, so we're like, all right, I got this. I know how to count, no problem. But wait, hold on. I'm going to call this B and this is H. All of a sudden we're like, wait a second, the heights of our little rectangles are changing. Foo! So we can draw little rectangles with the width that stays the same, but the height is changing. So shoot. Well, the easiest way that we could solve this problem would be to draw or convert our triangle into a rectangle where we say this is H and this is B. And so area of the rectangle would be, this is B, would just be B times H. And then we recognize that these two triangles are the same size. And so we're like, okay, the area of our triangle is 1/2 because we're only looking at this part. Base times height. Pretty straightforward, right? So that would be the counting method to find the equation for areas of different types of shapes. In the third part, we will actually look at how calculus gives us these equations. And literally, all we're doing in integral calculus is this. We are taking little shapes and adding them together and then counting them up to find the area of that particular shape. Pretty rad, right? Okay, so I'm going to end part 1 here. In part 2, we are going to use this understanding of adding up smaller pieces to get to a larger whole, to solve for the equations of area of a parallelogram, also a really good word, and area of a trapezoid. So check out part 2, yay!